Okay, let's continue finding the sum of square for the interaction between A and B. All right, so based on this, as we can see here, to finding the interaction, okay, sum of square, you will need x11, x22, x21, x12, n11, n22, n21, and n12. So how do you figure this out? Okay, so let's go back to our table here. Right, so the x11 is actually referring to the first row and the first column, whereby this is the second row and the second column. Okay, remember. Okay, the number refer to I, J. I is for row, J is for column. Okay, so let's take a look at the table. Okay, this is x1, the first row and the first column. Okay, and then this is x, the first row and the second column. Okay, whereby for this x, okay, the second row, so here, this is row, okay, this is row, and this is column. Okay, row, column. Okay, so this is the second, okay, the second row and the first column, and this is the second row and the second column. So how do we get this particular value? So we add this, right? We add this. So for x11, let's calculate. Okay. Okay, let's calculate. All right. Okay. So x11, 26.7 plus 25.2. Okay, you will get 51.9. X12, 28.6 plus 29.3. You will get 57.9. Okay, x21, 32.3 plus 32.8. You will get 65.1. And x22, you will get 26.1 plus 24.2. Okay, you will get 50.3. Okay, and now let's transfer this to the formulation. Okay, how about N11? Okay, N11. So how many you have? So you have two. One, two. So two N12 equals to 1, 2 equals to 2. And 21 equals to 2. And 22 equals to 2. All right? Okay. So let's transfer this into formulation. Okay, so uh x11, okay, 0.9 plus x22, okay, over 2 plus 2. Okay, this is square plus, okay, plus x21, 65.1 plus x12, 57.9 square, 2 plus 2. Okay, minus 225.2 square over 8. Then you solve this. Okay, you solve this. Okay, you solve this. Okay, 0.9 plus 3. Okay, 102.2 square over 4 plus 4.1 plus zero point 0.9 square. Sorry. Okay, 123 square over 4 minus 225.2 square over 8. Okay, and then the answer, okay, you will get 54.08. All right, so that's how you figure out the value for sum or square of the interaction. Okay, and for SST, okay, given that, okay, summation of x squared equals to um 6410.36. Okay, so how do you get the summation of x squared? It means that, okay, you add all by square root the value up to all value. Okay, all value. So you will get this. Okay, remember to use your calculator to get the fastest way lah for the summation of x square. So summation of x square is 6410 point 36, and then the formulation for SST is equals to summation of x square minus summation of x square over n. Okay, and then you will get 641. Okay, okay, you will get 6410.36 minus 225.2 square over 8. You will get 70.98. Right? That's for the interaction. Okay. Now, let's take the hypothesis. Okay. Uh, we will follow the examples as previous notes. Okay. How do you write the hypothesis testing for interaction for independent variables? First, the first independent variables and the second independent variables. Okay, for H now, okay, there is no interaction effect, okay, between uh, type of gasoline used and type of automobile driven on gasoline consumption. Okay. And for the alternative hypothesis, H1, there is an interaction. Okay. So this is the difference between the null and the alternative hypothesis. Whereby you just use the same word for this particular. Okay. So you continue writing up until on gasoline consumption. Okay. How about the independent variable effect for gasoline effects? So for the null hypothesis, okay, there is no difference, okay, between the means of gasoline consumption for the two type, because our levels now we have two types of gasoline, okay, and for the alternative hypothesis there is a difference, okay, and then you copy up to for the two types of. Make sure you write this as a full hypothesis. Okay, this is examples. Okay, I do I hope that you understand. Okay, what are the null and the alternative hypothesis between and what are the difference between the interaction effect and the four independent variables. Okay, how do you write this particular hypothesis? And then for automobile effects, you will use for the null hypothesis, there is no difference, okay, between the mean of gasoline consumption for the two types of automobile. Okay, and for the alternative, there is a difference. And then you have to write it full, for the two types of automobile. Okay, so this is how you write the hypothesis for two-way ANOVA. Means that you have three, interaction, independent, the first independent variable and the second independent variables. And for finding the critical value, my suggestion is you complete the summary table first. Okay, you complete the summary table first, and you will get this, A minus B, 2 minus 1 equals to 1. B minus 1, 2 minus 1. Okay, 1 times 1. And then 7 minus 3 equals to 4. And then you will get 7. Okay, and we transfer the sum of square that we calculate before this into this particular table. Okay. Okay. So you get the total first. Okay, remember you get the total first because uh here we calculate the total, we calculate the total. And then how do you get this particular value for error? It means, okay, SSE equals to SS total minus SS A times B minus SS B minus SSA. Okay, you will get this particular value 3.30. Okay, and then you just complete the mean square. Means that, okay, you divide. Okay, divide the sum of square with the degree of freedom. So MSA equals to 3.92, MSB equals to 9.68. There is no difference between the value because we divide the value by 1. Okay, the degree of freedom for all of A, B, and the interaction is 1. So that's why there is no difference between the mean square value and the sum of square value. Okay, I hope you don't confuse with this. Okay, and then the MSE. Okay, so 3.3 divide by 4. Okay, so you will get the value. Okay, for this. And then um you just divide this. This is actually MSA, okay, over MSE, MSB over over MSE, and this is MSA times B over MSE. Okay, so you will get 2.92 over 0.825, 9.68 over 0.825, 54.08 divided by 0.825. And then you will have your value for the test statistic for each of these. Okay, so let try this example and make sure that your answer is the same as me. Okay, so for the critical value, okay, as I mentioned, it depends on the degree of freedom for your for the source of variation and the error. So for each of these hypotheses, you have to compare FA versus F1 4, FB, okay, versus F1 4, and F A B versus F14. Okay, for these particular cases, as we can see here, okay, the degree of freedom for V1 and V2 is the same because as we can see here, across this value for the degree of freedom, sorry, for the degree of freedom, okay, the degree of freedom is the same. Okay, uh, we need alpha value. So it tests what are the alpha value. Um, okay, test using alpha equals to 0.05. Means that, okay, for each of these critical value, you will use alpha equals to 0.05. Okay. So the critical value F 0.05, V1 is 1, is V2 is 4, is equals to uh, equals to uh, 7.71. Okay, you can check with the table. All right, and then uh make the decision. Okay, so this is the decision. Since FB is and FA times B are greater than the critical value 7.71. Okay, so the decision rule is actually, okay, reject H null if F calculated is greater than or equals to FCB. Okay, so from here we can see that FB and F, the interaction, okay, A times B are greater than the critical value 7.71. So for this particular F, we reject the null hypothesis. Okay, and since the interaction effect is statistically significant, no decision should be made about automobile type. It means that, okay, suppose that you get the significant, the independent variable, one of the independent variables rejecting the null hypothesis, and also the interaction also rejecting the null hypothesis. So, uh, you should not. For this particular example, then they do not proceed with the automobile type because actually you will get this. Uh, okay. As we can see here, you will get the there is no decision. Even though if you compare with the null hypothesis, it seems that FA is not rejecting the null hypothesis. Okay. So for the conclusion, since Sechner for the interaction effect is rejected, it can be concluded that there is an interaction effect between type of gasoline use and type of automobile driven on the gasoline consumption at 5% significant level. So this is how you write your hypothesis for two-way ANOVA. Okay. And as we can see here, this is the Minitab output for example 15. Okay. So this is example 16. Okay. So uh, as we can see here, the p-value, okay, this is less than alpha 0.05. So means that it is the same as when we doing our critical value approach. Okay, so we also rejecting the null hypothesis for the interaction. Okay, and for this particular example, the effect of the type of gasoline use and the effect of the type of automobile driven are called the main effects. So means for this particular okay, I will highlight using the green. So for this particular green, okay, for this particular green, we say that this is the main effect. Suppose that the interaction effect is not significant. Okay, suppose that instead of you get the rejecting for the interaction, okay, you can proceed. Okay, the interaction effect is not significant. The strategy of analysis is to proceed with the analysis of main effect. Means you can do the hypothesis for the independent variables. Okay, so that's why when we doing the two-way ANOVA, uh, the things that we actually want to study is actually the interaction between A and B. So uh, that is mostly our main objective when we doing the two-way ANOVA. Right. Okay, so for example, it's 17, I will leave it as your examples and we will discuss this during our class session. Right? Okay, I think that's all for my video session. If you have any question, you can ask me. Right? So thank you for listening. Bye.